This video introduces Reflexion, large language model-based agents with verbal reinforcement learning. Reflexion agent is an AI agent framework to reinforce large language models, not by updating model weights, but instead through linguistic feedback. Namely, AI agents learn from prior feelings by using verbal reinforcement. By reflecting on past actions and identify errors, AI agents can improve the strategies and enhance the performance without expensive model fine-tuning. And reflection agent can solve decision-making, programming, and reasoning tasks by optimizing their own behavior through trial, error, and self-reflection. Here is a procedure for decision-making, programming, and reasoning. The verbal reinforcement is explained here. And the reflection agent consists of three distinct modules, namely an actor MA that generates text and actions, and an evaluator ME that stores the output produced by MA, and self-reflection MSR that generates verbal reinforcement cues to assist the actor in self-improvement, as shown here. The actor is built upon a large language model and prompts the large language model with a current trajectory and the experience to generate the necessary text and actions conditioned on the state observations. The action generated by the large language model is conducted on the environment, and the reflection agent receives a reward or observation from the environment, as shown here. The evaluator assesses the quality of the output produced by the actor and computes a reward score using the generated trajectory as input. Since it's difficult to define reward function for reasoning tasks, for example, reflection agents define reward functions based on exact math grading to ensure that the generated output aligns closely with the expected solution. However, for decision-making and programming tasks, reflection agents employ predefined heuristic functions that are tailored to specific evaluation criteria, or a large language model itself as an evaluator to generate internal feedback. Self-reflection is instantiated as a large language model to provide valuable feedback for future trials by generating verbal self-reflections. Given a binary signal, the current trajectory and his persistent memory, the self-reflection generates nuanced and specific feedback. This feedback is stored in the memory. The reflection agent leverages his experience to adapt his decision-making approach at time t by choosing correct action. This iterative process of trial, error, self-reflection, and persisting memory enables the agent to rapidly improve his decision-making ability in various environments by using informative feedback signals. Here is a pseudocode for reinforcement for self-reflection. At inference time, actors' decision conditions on short and long-term memory, similar to the way that humans remember fine-grained reasoned details while also recalling distilled important experience from a long-term memory. In the reinforcement learning setup, the trajectory history serves as the short-term memory, while outputs from the self-reflection are stored in long-term memory. These two memory components work together to provide context that is specific but also influenced by lessons learned over several trials. Reflection is formulated as an iterative optimization process. In the first trial, actor produces a trajectory tau zero by interacting with the environment. Evaluator then produces the score R0 from ME to amplify R0 to be feedback form that can be used for improvement by a large language model. Self-reflection analyzes the set of R0, tau 0 to produce a summary as R0. That is stored in the memory, MEM. Actor, evaluator, and self-reflection work together through trials in a loop until the evaluator deems tau t to be correct. After each trial t, SRT is appended to the memory MEM. For more details, please check with these references. Thank you. Bye.